Uh, I'm just gonna do a quick sound check to see if everything works. And we're gonna see if I can hear myself. Okay, I can hear myself alright on the stream. So I'm just gonna post this information on Facebook that we're starting, or on Twitter maybe. Okay, so I've only gotten 2 responses to my poll, but we're gonna get into that a little bit later. So I'm Christopher. I'm a software engineer with over 3 years of experience in JavaScript development. I started the stream because I want to have an opportunity to implement some algorithms that I did not use in a very long time. And also I would like to get feedback from people and get some exercises from them so I can try to solve those issues that people are having if they're interesting. So basically there were 2 entries in the poll, and the first one was triangle inequality. The second one, which I've chosen myself, is order statistics. And maybe we're going to have some suggestions later on from the people on the stream. And we're gonna wrap this up after that. I think it's going to take a little bit, it's going to take somewhere between half an hour to an hour. And you can see my YouTube link over here. So I'm gonna just go on. I'm not sure if I'm logged in here. Yeah, I'm not. So I'm just gonna hide the stream for now and post on Facebook that I'm live, but I'm just gonna be back in 1 or 2 minutes. Okay, so that was the last break, and I'm just gonna start the first assignment. So I'm just gonna go into the directory that I have for streaming code. I'm just gonna make a directory called triangle inequality, and we're gonna start coding. Basically, triangle inequality is this property of a triangle that that states that both of the edges of the triangle, that all of the edges of the triangle have to basically hold this hold those inequalities to be true. So if you take any of the any two of the edges, the sum of their lengths has to be higher than the longest edge of the triangle. And if I'm gonna check out who requested that that assignment, and we've got Paul as in P0LE, and he suggested that, and I'm gonna try to implement that. Okay, and do we have Paul on the stream? If Paul is on the stream, can you just write something on chat? I'm gonna check that later. Okay, so that's going to be quite easy thing to implement. Let's see, we're gonna write a function that's basically going to check if those three things are true, right? So we're gonna check if a plus b is greater than c, and we're going to check if a plus c is greater than b, and we're going to check if b plus c is greater than a. And if we try to call it with 3, 4, and 5, so that's a valid triangle, we should get a true value. Yeah, and we got it. And let's just check the stream if we have an example that doesn't work. So if we have an example that that's not actually a valid triangle, so he suggested something like that, and we can check now that we get false. So that's pretty easy exercise. And what we're gonna do next is we're gonna check that all of the arguments that we've passed are actually numbers, because we can only work on numbers in this context. So number is not a number, is finite. I don't know if in JavaScript we can check if it's a number, basically on the number constructor. How can we check the type? We can check type of, so basically type of 5 is going to be a number, and we can do it that way. It probably is not not always you can probably get an object that acts like a number, but for the purposes of this presentation, I'm just gonna check it like that. So type of A is not equal to number, or type of B is not equal to, or type of C is not equal to number. We're gonna return none, because that was what was expected. And we can check it now. If it works, it's false, and if we basically provide it with a string, for example, so string, we're gonna have none, and that's okay. Please increase the font size. Right, font size, editor font size 18. Can we check it now? Okay. Okay. So I'm just gonna run through that code quickly, because a couple of people joined in and suggested increasing the font size. So triangle inequality, we have to check that the edges of the triangle fulfill those inequalities, and if we get anything other than a number, then we will return not a number. And as we can see, we can try and uncomment these examples, so we can see all of it in action. Okay, so we get, for the first one, we're going to get true because that's a valid triangle. For the second one, we're gonna get false, and for the third one, we're gonna get none. Okay, a little bit more. All right, 21. How about that? Oh, size. I don't think that changed. Do you have the highest possible resolution? Because as you can see on my preview, if I enable the highest resolution, it should be quite alright. I'm not on Windows, but if you can confirm that this is readable. There's a little bit of delay, but that should be more than readable, and on the terminal it also should be fine now, I think. Okay, for me it's okay. Alright, so if you guys have any other challenges for me, just post it on the chat, and I'm gonna go get back to them after I solve the second challenge. So okay, we're gonna go out from this directory, and we're just gonna create another one. The second exercise is going to be order statistics. So I'm gonna create a file as usual, and just start the editor there. Do we have a proper font size for this? Okay, it's there. Go to preferences, user settings, alternatively command, but I do think that the font size is quite big enough. Can you confirm that after I change it, it's okay? I can just go even bigger, but that's going to be a little bit hard to put a lot of code onto the screen. You don't need to worry about if you're not able to see the left side, because this is going to be only in one file. Okay, so if you guys have any questions about the previous example, just let me know. And if Paul is on the stream, you can check if the example I provided here is the thing that you were looking for. I'm just gonna post that on GitHub and post the link onto the stream so you can check it out. And let's find them. Okay, so create public. We're gonna. Okay, so if everything is alright, then we're just going to continue. So the second example is a bit more complicated because we're going to look at order statistics, and order statistics is basically picking the nth smallest number from an array. So if we have an array like this, and we want to pick the first smallest number, it is going to be 2. Basically, we can put it on. And if we want to pick the second smallest, it's going to be 3, and third smallest is going to be 4. It's at the end here, and so on and so on. So it's a little bit like sorting, but we don't want to do all of the work that sorting requires, so we don't want to put all of the elements of the array in the sorted order, but we just want to know, for example, what's the third smallest number in the array. If you guys have any questions, I'm gonna check the chat periodically. I don't know if I can put it somewhere. I'm just gonna basically install another monitor and have the chat there, but I didn't have time to do this for this stream. But I'm gonna check it to see if you guys have any questions. Okay, so we're just gonna start with something really easy. So we're gonna just start with picking the smallest number, and after that we're gonna grow that example from there. So we're gonna call the function and_smallest, and it's going to pick it's going to take an array, and it's going to take a integer n, a number n, that's going to say which number it is. And at the bottom, we're just gonna have an example function that's going to call it, and we will check if our implementation is wrong or right. My array, and we pass, so we can pass basically 1. Okay, and we want that to be equal to 2, so if we call it that from the console, we're getting false, so it's not yet working, even for this use case. And another one is going to be 3, and after that it's going to be 3 and 4, right? Okay. Alright, so we're gonna start with the simplest version. So what we can do is we can iterate over the array and pick the smallest element and basically return it. Iterating over an array is like this. So we can start with a initial value of min. So we're gonna store our minimum value here, and after that, if we encounter something that's bigger, that's smaller than that, then we can switch our mean value to that value. So if the array that the element of the array that we're currently looking at is smaller than min, then min is going to equal that value, and we return that min value, and we can check now if our first test passes, and as you can see, the first one is true, so the minimal example is done. Okay, so how we can go from there? If we know how to get the smallest one, then adding another one should be quite similar. So we're just going to add another one, and we're going to have another if statement here. So right now we're only checking that we're only checking 1. So if this is true, then we had a smallest number in an array in min, but we found something that's smaller, so we basically push that value to the min2 variable. So min2 is going to be equal to min, because we push that value a little bit further, and we change that one to this one. And we have another case that the second min is going to be in between them. So there's no comments. So if the element that we're looking at is smaller than the second smallest element, then what we do is we just replace that one, because the smallest one still doesn't actually change, right? Okay, and if we want to as you can see, we're not even touching the n variable. So at the end, we're going to check if n is equal to 1, then we return the minimum value, and if n is equal to 2, then we have to return it, right? And that is that code. And now we can add another we can add the fourth smallest to have some more tests, and this fourth smallest is going to be 6. If you guys have any questions, as I said before, go ahead and ask them on chat. Okay, so we added another test case, and we implemented smallest value in an array and the second smallest value in an array. So we should get, as we've expected, 2 of them are true, and 2 of the tests are failing, because we only check for 2 use cases. Okay, so actually we don't want to continue with this and add another variable that's called min3 and repeat that, because it's not going to solve the issue in a general case. What we want to do is we want to have a general algorithm that's going to pick that number, whatever we put in. And as you probably already guessed, this problem is pretty similar to sorting. So one way we could actually implement it is to go with we call this function cheating, and what we're going to do is basically sort the array and return the element that's at the nth position. So let's make a copy of this, because in JavaScript sorting is mutates the array. So if we change the value of the array, we basically don't want to change the actual value of the array. We want to overwrite that, and we don't want to overwrite that. We just want to work on a copy. So we're just going to copy the array. This thing is from ES6. I believe it's the deconstruction operator, and adding brackets over that, we basically tell to the JavaScript engine to deconstruct that and put it in an array. So it's like doing a copy. And we're going to sort. I don't know if it's going to work without a function. So, and I never remember how if we have to do a minus b or b minus a. So we're just going to check that in a moment. So let's just call cheating off. We have to do it. Yo, my array. The end is not used right now, so it actually doesn't matter. And let's comment this out. Okay. All right, so it did not sort it at all. What if we do sort? Just sort. Okay. Jesus. Let's just do sort without anything. Ah, yeah, I'm console logging the wrong variable, right? I'm console logging array while I copied it, so no wonder it did not change, right? So this part did not change because we did it on a copy, and we were outputting the original array. So we checked that our copying works. Okay, and we have a sorted array, and as you can clearly see, this is going to, well, I don't know, I don't want to debug console. Cheating. We can now return copy of n plus minus 1, right? Because we count the indices of an array from 0. Okay, so wow, as you can see, this passes the test, but we're doing more work than we actually need. We actually want only to do enough. We just want to do enough work so the nth element is that we know the nth smallest element, but we don't want to move whole of the array around. So we can actually do that, and we don't have to do that much of work. Okay, but our previous attempt is going to the, well, maybe I'm just gonna copy it and or just start a new function, smart array and n. Okay, so let me check if there are any questions. Okay, I'm getting an error here. I hope I'm streaming still. It looks like I'm streaming on the software that I'm using. Yeah, and it's still going. Welcome to live chat. Okay, should be alright. Okay, let's go back. So we're gonna call that smart and smallest, and this one is going to only do the work that's required, no more, no less. So if we look at that problem, what we actually want is that if we're picking, for example, let's say that we want third smallest element. Okay, so the third smallest is going to be this 4 over here. So when we're sorting things, if it's a quick sort or something like that, we're going over the whole array and we're putting every element in the right correct place. But in this example, we don't actually care if the array is going to end up looking like, for example, 3 to 4 that we care about. That's the index we care about, and we don't care if the rest is, for example, 12, 7, and 6, for example. We don't care if that part is sorted. We don't care if this part is sorted. We only care that our 4 is in the right place. And we're going to basically take that principle and try to decompose this problem step by step. So if we start with an array that's not sorted and we don't know what's in there, but we can pick an example number from that array. Let's just stick with the third smallest. We know that's 4, and we're going to pick an example number 6 from this array. So our special value is going to be 6, and that special value, we know how we basically know how to split this array into 2 parts. We know that we can have numbers that are smaller than 6, so 3, 2, and 4, and the second split value is going to be 6 we picked, 7 and 12, right? So now maybe it's not obvious at the first look, but the length of the array tells us where our number that we're looking for is located. So we're looking at the third smallest. So this array has a length of 3, and we know that all of the numbers that are there are smaller than the 6 that we wanted. So we know that that number has to be somewhere here in this first array, okay? And what we can do is discard the rest of the second array, because we don't care. If we actually took something like 5, so then the first array is 3 elements long. The special value that we took is 6. That's the fourth value, and we know that it has to be greater than the fourth smallest value, so it's somewhere in the second array. So we can then discard this part of the array and start looking here. So this is going to be a recursive algorithm, and based on what's the length of each array and what's the special value that we took, we're going to decide what we go do there. And I'm gonna just do a little pause here and give you guys a chance to write any comments if you have anything. to ask, because that's quite a that's something that that's quite tricky here, and that's the core. That's at the core of the algorithm. So I'm gonna just take a little short break, get some water. And if I don't get any comments, I'm going to continue. Okay, so just to remind you guys, if you have any other exercises or any other suggestions that I might do live on stream, just post your ideas on the chat. And if not, wait, yellow. Okay, if not today, maybe on another stream, I will be able to help you. Okay, so let's get back to this example. Maybe we're going to split that, everything that we talked about into smaller pieces. So we talked about splitting the array, and let's just write that function down. So we have one little piece, and we can then start to compose things from that. So let's call it split. I don't think it's going to clash with anything. And let's continue with the name special value. And what we can do is use something like this, smaller. Okay, so maybe we can just go first smaller. So we take our array and we filter. Filter is a function that takes a function as an argument, and that function takes a single argument which is a value, and it should return a boolean that says whether to include the value that we got into the result, or to discard it. So we wanna have we want to include all the values that are smaller than our special value, and with the bigger part we're going to do the same, but we're just going to select bigger elements, and we're just going to return those two parts that we got. So we can test that. We can test that on. Let's have our example here, and let's uncomment this and comment that out, and let's go split on my array, and we take our special value, for example 6, as we said, and it should split the array like that. So let's check it. Oh yeah, we need to output it. Okay, so we get two parts. The first one is 3 to 4, which matches the thing that we expected, and the second one is 7, 12. So that's also okay. All right. We got that splitting part, and I think that we can start looking at implementing the bigger function. So let's delete this, and let's do something like this. So let's pick the special value as we said, and in the example I've just picked a first element, and there's nothing wrong with doing that. So special value is going to be array or at the index 0. Okay. We got that one. Then what we're going to do is to get those two splits, the smaller the array that has the smaller values and the bigger values. So let's split our array by special value, and for now let's just also log that smaller and bigger, and let's just have smart and smallest and array and dot. Okay, so the splitting still works. It's great. Okay, so this is the moment that we have to decide whether our value is in the left array or in the right array. So if the length of the smaller part is smaller than the value that we're looking for. So if we're looking, because this is a bit tricky, because length for the one element array is going to be for the one element array is going to be 1, but the index of that is actually 0. So 0, or maybe something like that. X over 0 is 0, and if we get like 7, then it's 7, but the length of x is actually 1. So here are edge cases that we want to think about, because the indices are a little bit messed up. So, but I think it's going to be alright. Let's check if the length. So for example, we have the values that we had here. We're looking for which one? For n equal. Let's for now think about when n equals 3. Okay, so this is going to be 3, and this is going to be 3, and it's not going to be equal. So it's not going to be smaller. So we actually want to think about length minus 1 or n plus 1. Let's go with n length minus 1. So we are thinking about 3 here. The length is going to be 3. This is going to be 2, and we're going to end up in this region. And if we end up in this region, what we want to do is just reduce our example. As I said, we discard this part, and we go into the recursion with smaller, this is this part, and n doesn't change, right? Because we're still looking for the third element, right? Okay, so the second thing that can happen is actually that our special value is the n value, the nth smallest from the array. Is that it's that what we're looking for. So what we want to do here is check if this is equal to n, right? So if we're looking for, let's say, fourth, if we're looking for the fourth smallest, that's going to be, this is going to be 3, that's going to be 2, and we're looking for 4. Okay, so I don't think this is going to work that way. I think we need to do it like this, because otherwise we're just going to not be able to write this if statement. Okay, so now it's going to make a little bit more sense, because this is going to be 3, right? Because this is 3, and the n plus 1 is going to be 4. So okay, so this is going to be smaller, and if we were looking for the fourth one, and the fourth one would be okay, and if we took a special value, another special value, if the special value was actually, well, we need to do it another way. Let's do it like this. We don't change the n, we just change the special value that we took. Is 6, and in this so let's just say that we actually took the right value. So the third one is 2, 3, 4. So the special value is 4, and we have something like that, and we have 6 here because we did not take it out. So that's actually that actually would make sense to just, this is going to be 2, and n is still 3. So what we have to do is have it like that. All right, so okay, so this smaller length plus 1 is equal to, okay, so if this is smaller and we put 1, okay, but we're jumping to 2 values here. I think that we just basically need to do something like maybe we need that. Let's just leave it like this. But I think we're getting ourselves into trouble. But I'm gonna debug it another way. Okay. So the last way we can end up is that our special case is going to end up in this part. So if our is if it's larger than this one, let's continue. We're just going to step by step through that in the debugger. I think so, because it's going to be a little bit of tinkering. Okay, so if we end up in this part, okay, here we basically just return, and we have return here as well. We're going to return our special value, and here we're going to return smart and smallest, and our solution is actually in the bigger part, so we're going with bigger. And now we have to subtract the length of the smaller, because first we were looking for example for the fourth smallest value in the whole array, and if the smaller array has the length of 2, then what we need to do is subtract that 2, because we removed that from our perspective, so to say. So let's just go with we got smaller length, and we want to subtract that from the n. Okay, I still think that we have a bug here, because that's not consistent with the other stuff, so I'm just gonna put it here. So length 3 plus 1, we're looking for that might work. Let's just run it and see, and we may get a exception that we exhausted the call stack. Let's take those examples here and just run it and see what's happening. Yeah, maximum call stack exceeded. Okay, so we have a little bit of a debugging session going on. We're just going to run the debugger and run the inspector. Probably I have to increase the font size here as well, so you guys are able to see. Well, maybe not that big. Okay. Alright, so here we define stuff, and here we're actually going into the values. So we take our special value, it's here, it's 6. We're doing the split, so in smaller we have 3 to 4. Okay, so here is 3, we're looking for the first one. Okay, alright, so what we do here is we're not going to come here even, because we have our assignment wrong, right? We have our condition wrong here. So we're looking for the first one, and we're not even ending up in smaller. So basically this is definitely wrong. So our n has to be smaller than this one. So I'm not sure if we don't have to just convert .n into a smaller value, but let's see. Okay, so this is going to tell me that n is in the right place. Okay, so if n is bigger, but let's run this version. And so the nth smallest number is smaller than the size, so it's definitely in here. So we go into this branch, and let's start it. Let me just get another cup of water. Alright, so I think we need to close this one and start this one. Okay, we go into this. Our special value is 6. We split. We get our n is 1, so 1 is definitely smaller than 4. Yeah, as we can see, so we're going to end in this branch. And we have another split. Our special value now is 3, so we're going to split over 3, and smaller value is 2, and n is definitely 1, so we still end up in the smaller branch, so it's 2, and we start the recursion again. Our array is 2, which is basically our special value is going to be 2. We're going to split. Those two arrays are empty, and now we should escape with a special value. So n is 1. This is false. So alright, and we have to check this. Yeah, it's going to be right. So we're going to end up here, and we recursively end up here. Alright, so and we get true as we suspected. Okay, so I think we fixed the bug that we had. Alright, so let's uncomment these things, and oh, cheating is not defined, right? I forgot to change those. Maximum call stack exceeded. Okay, so there's a bug somewhere else. So we get true, and on the third one we get some sort of an error. I thought we got it, but I think that this part right now might be wrong. So let's go into that example as well. Let's go into the inspector. No new comments. Let's continue. Okay, so we define our array. Why isn't it? Jeez, it did not refresh. Maybe I did not save. Yeah, I did not save. So let's do that again. All right. Okay, let's go into this one, and let's see our variables. We do the split, it's the same, but okay, so this we're going for the third smallest. Smaller are is the array here, so it's 4 and this should be 3, right? So we should go into this one. Okay, so we go into this one, and now our array is here, the special value is 3. We do the split, so bigger should be our target now. This is equal to 2, and we're looking for the third smallest, so we don't go into that branch, but we should go into this branch, right? This is 2, and we're looking for the third one, and we're probably right now we're probably looking for something wrong. Okay, so n is 3, this is equal to 1, right? All right, so we actually forgot that the special value that we take is not included in a bigger array, right? So after we know that our solution is not in those two branches, so we know it's not in smaller length. We know that it's not in smaller length plus 1 because we omitted this branch as well. So we are missing. We should be actually doing here minus smaller length minus 1 because we actually omitted, we actually did not take into account the special value that we also did not include in the bigger value, bigger array. Okay, so I think if we do something like +1, so we're taking into account now both of these, we should be good to go. Let's do this and let's do that. Voila, we have a working example. Okay, so that was a bit exhausting, and just to wrap this exercise, why do we care, and why not just sort it and have it that way? As we probably know, sorting is O of n log n. So this is the complexity of sorting by comparing values, because we can actually do O of n using some other sorts, but that's the complexity of sorting. And if we do this way, let's think about it, how that will look. So if we want to actually think about complexity of this, so we start with a first thing that we iterate is here, and we iterate in this example. Actually, we do it twice, but we can rewrite it to do it only once. So let's go for it. Let's just go and do this. Why do we iterate twice? Because we had two filter functions and we did it twice. Let's just do this in one pass. So let's just do for smaller than and let's just whoa, let's just do if if array of I is smaller than a special value, then we put that in the smaller value. If it's bigger than a special value, I'm just doing that so we have when we calculate the complexity of it, it's a bit simpler. Bigger, okay, and smaller, bigger. This should be equivalent of that, and let's just run it and see if we get the same results. Yeah, we get the same results, so we didn't screw it up. Okay, so here we're going to do O of n operations, and O of n is going over every single value of that. All right, so based on our split here, so let's just call it 1. Based on that, if that split is kind of fair, so we have half of our values in the smaller array and approximately half in the second smallest, then here we recurse over n over 2, right? Okay, and we do that over and over again, and when we do that, it's going to be at the first iteration, it's going to be n plus O of n over 2. This is at the first iteration, this is at the second. Then we take that and we go over half of the half, so over 4 plus O over n over 8, and so on and so on. And if I'm right, then this actually tends to the value of 2 times O over n, right? And in the O notation, we discard that, so it's going to be basically O over n, right? Let's just check if I'm kind of right. So 1 plus 1 over 2 plus 1 over 4 plus 1 over 8. This is something like that, and if we continue, we're just going to get closer to 2, but we're never gonna reach it, right? So so our complexity here in a quite a good good example, in a quite a good array that we get in a quite a good split, we're going to get approximately O of n. So this is a lot better than n times log n. Okay, so what's going to happen if this is actually a bad split? So if our split is going to be usually something like one element here and a bunch of elements over here, and we're looking at the last, for example, value, then what we're going to have here is not n over 2, but we're going to have n over n minus 1. And if we sum it up, then what we're going to get is going to be O over n plus O over, well, maybe let's not just call it like this, O over something, let's just call it like this. And we're going to have something like this, minus 2 plus n minus 3, and if I'm not mistaken, it's going to be O of n squared, right? Because it's going to be, I think so. Let's just Google that to make sure. Yeah, you can see that it's n times n minus 1 over 2, and n, just write it down, n times n minus 1 here, n minus 1 over 2, right? Okay, and that's pretty much n squared, right? So like with sorting, if we get a bad case, it's going to be n squared. So you can say that to be safe, we can just sort the array and have a n log n. But one improvement to this is that we can actually pick a random element here, and if we pick a random element there, we're going to get a guaranteed amortized time to be O of n. Okay. I think that's pretty much everything that I wanted to explain here. Okay, I've lost 2 people over this. As you can see, that 3 people are now watching. Okay, so I think that's pretty much what I wanted to cover in this session. I don't see any other ideas. I'm just gonna quickly check. I'm just gonna check quickly the poll that I posted to see if there are other answers. No, still 2. Okay, so that's pretty much it for now. I had another person posting the question on Facebook group, which who was Adil, and he wanted to get a system that allows uploading video and watching it on the web, so pretty much something like YouTube. And that's a pretty big one, and I don't think I'm gonna make such long streams. That may change in the future, but for now I'm not going to do streams that long. So I think that in the future stream I might go over an overall architecture of how someone would go about implementing a small YouTube clone, but I don't think there's going to be time to implement the whole thing. Okay, so what I think is I'm just going to copy this, put it on in a gist, and share that with you guys so we can play with it. And we're gonna finish for today. Okay, create a public. Okay, so that's it. If you guys enjoyed it, let me know in the comments, and I might do another one. If you have any ideas for exercises that you wanna see me solve on stream, just let me know. Also in the comments or um, in the poll that I posted on Facebook. And thank you for watching, and see you guys next time.